Welcome to What Is, a series where we aim to answer some of the more complex questions around the 36th edition of the America's Cup. In Episode 3, we'll explain the engine above deck, a term you might have heard on the TV commentary. We've turned to our North Sails experts to fill us in. Watch and find out. Like we've previously explained, there are lots of components working together to ensure these boats go as fast as possible. First and foremost, it's important to clarify that the engine above deck is an expression. There is no literal engine on an AC-75. Rather, it refers to integrating the aero, the North 3DI sails, the Southern Spars rig and Future Fibres rigging with the boat's hydro package, the AC-75's hull and foils. In the 36th America's Cup, all the systems need to be designed to work in harmony to maximise performance potential. The engine above deck is made possible because of the North Design Suite software. The Design Suite is a powerful piece of software that is able to build a three-dimensional shape of a sail and rig to determine the flying shapes, the stresses and the strains going on in the sail and rig. The North Sail designers working on the AC-75s rely on 5 different programs: Desman, Spiral, Warps, Flow and Membrane. The data the designers receive from these 5 programs help the designer with making very confident decisions with their sail designs right from the start. These programs help bridge the gap between concept and reality. To help you understand all of this and how it works in the real world, let's go sailing. First, let's imagine a boat at a dock. The sail design process starts with Desman, where the sail designer engineers a 3-dimensional model of the rigging, mast and sail, along with their mechanical properties. This is our simulation platform. Back to our boat, this is the point where we cast off. Next comes Spiral and Warps. Spiral builds the sail shape, while the designers use Warps to establish the sail structure. For 3DI, Spiral ultimately determines the shape of the 3D mould, and Warps helps the sail designer define the composition of 3DI tapes and writes the blueprint for the tape layout. Now it's time to go sailing, except with NDS we go sailing virtually. For this, the sail designer calls on Membrane and Flow, a powerful pair of simulation software. Membrane uses data from the wider suite of North Design software to simulate what happens to the rig and sail structure when it's subjected to different loads. As the structure is deformed under load, the shape of the sail changes, and Membrane pushes the data to Flow, which applies wind pressure to sail surface and calculates the forces created. The iterative process revises the sail shape in Membrane in a circular feedback loop until a stable balance is achieved. In short, the duo allows a sail designer to run infinite simulations with incredible accuracy on how a given sail shape will work as a scale. North Sails invented the scientific approach to sailmaking, and today the North Sails Design Suite is the most powerful and diverse sail design tool in the industry. The cool thing about the whole process is that it's not just a tool for designers, it's ultimately for the benefit of the customer. In this case, an America's Cup sailing team and their design team. One thing that's evolved over the last decade is that in the past, developments needed to be verified with 2-boat testing on the water. With the software becoming so much more sophisticated, the developments we make in the virtual world are accepted as being real, and the development cycle is much quicker. We know that's a lot to take in, and that's just the abridged version, but we hope this gives you a better understanding of what's happening on board when you hear the term engine above deck. Stand by for our next episode of What Is. Hit the subscribe button below and make sure to tune into all the North Sails coverage of the 36th America's Cup.